Hi, welcome back to Project Frankaru. Bit of a milestone working on Chapter 10, so I think I'm a little past the halfway point. There's still a lot more to go, but progress is being made and most of the big parts are in the car. Seeing as all the large components are in and there's not a lot of things that are heavy to add, I went ahead and weighed the car. So kind of wanted to see where we're at, see how I'm progressing. And so I threw the front bumper, the radiator, and the cooling fan on the hood, and threw the hood on and said, okay, let's just see where we're at. And it turns out we're at 2308. Would have liked that to have been about 100 pounds less, but that's what it is. Looking at what I have to put back in the car yet, I'm thinking there's a little over 100 pounds left to add on top of that. So finishing weight should come in somewhere a little over 2400. And that's where we're at for the moment. Okay, sorry for the interruption. Anyway, so at this point, I'm at a critical juncture. This is one of the harder parts to do, and that is I need to mount my dry sump pump over here. And to do that, I've got to get everything rigged up and figure out where it's going to sit and how. So a couple of things I had to take care of first was how I'm going to drive it. Originally, I was going to do a jack shaft off of this big belt, slow down the output to the pump and everything, as I had mentioned earlier about not being able to run at crankshaft speed. Well, turns out since I got this nice ATI damper that only had one set of grooves, it was shorter. By being shorter, I had room to put another pulley up here for the dry sump pump that I don't have to get into this other drive system. Way simpler, much preferred. It's a little Gimler belt drive. So the parts for this I get from a company called Armstrong Race Engineering, ARE, out of California. Also drysump.com. I don't get any sponsors from anybody. Everything on this car, cash out of pocket, folks. I'm not getting anything from anybody. This is all just for information. So I'm having to buy all these pieces and oh, it's adding up. I'll get to the budget another day. Anyway, so ARE makes this nice little adapter here. This is a 16-tooth pulley that drives directly off of the ATI damper, bolts right to it. And then I can get my Gimler belt, come right off of this over to my pulley on the pump. The pump pulley is about twice that diameter, about 4-inch, so that works out just perfectly. Runs at half crankshaft speed. So another thing I had to do, since I was talking to them, was I've got to get the pickups out of the pan. And one of the things I did not do is I didn't put screens in the pan. Would have liked to, but it's difficult to do that, and how to attach and hold a screen and have fasteners that won't vibrate loose and end up in your oil system or something come loose. So rather than even bother with that, ARE has these very cool little things. It's an AN12 fitting, and it comes with a screen already swaged into it. So there's my pickup screens, and I've got one for each side for both of the pickups, and they just thread right into the pan. You got your screen, you protect your pump. How nice is that, huh? So that's another big help. All these little things come along. So now I'm going to get to the mounting plate that I want to put over here to mount the pump to. So I've got to come up with some dimensions and some material and start working on that. Let me show you where we're at. Okay, so this is my pump, and it needs to mount right about in here, in this location about here. So I've got to figure out how to mount this thing. There are two ears on it, and you can see they've got a bolt and a hole that swings to tension. So I can pivot it up to tension the belt. So I need to mount a plate or a block in the middle here, put holes through it to mount that. And to mount the block, I need to mount it to a plate. To mount the plate, I got to come up with where am I going to mount it from. Well, as it turns out, on this side of the block, there are several holes. And I need at least 3 holes to get a solid mount. 2 holes might vibrate. 3 is solid. So I've got 1, 2 here, and a third one up here. So if I can come off of these 3, I have a location point to mount a plate. So what I'm looking at is putting a plate right about where my hand is here, in this area, and then putting an L bracket off of this to it, another billet piece, and then my block mounted to that plate. So to come up with these holes right here, I need to figure out, well, how big of a plate can I fit in here? Well, let me grab my measuring tape. Okay, so if I start back here at this back hole and I come out front here, I've got to leave enough room between this and the plate to allow it to extend up here, because I know that's about where my pump ears are in here. So I'll have some extra I can trim back. But I think if I go with about a 6-inch long piece of metal, and then I want to go up underneath, come up from the bottom, underneath this tab here and down to my lower bolt hole here, I'm looking at, right in here, I'm at 5 inches. So as a good blank starting point, a 5 by 6 inch plate, and I need to make it thick enough to be stout, and I'm going to go with 1/2 inch thick plate. Okay, so let me grab a piece of metal and carve that out and be right back. So I've got myself a piece of metal, 5 by 6, 1/2 inch thick, and I've threaded 2 bolts in here. And I'm going ahead and putting the plate up against those bolt heads, looking at my gap here that I want, and thread them in and out until I get to the depth I want. Okay, and then I know what I need for spacers. So what I'm going to do is make 2 spacers for these bolts. Each one will be made out of 1-inch diameter aluminum and just drilled through. So I'll go do those on the lathe. And I'll make spacers as deep as these are. And they turn out to be right at 1 1/4 inches. I'll make those 1 1/4 inches long and put the hole through them. And then I can start working out where my holes go in my plate here. So let me whip up those and come back to you. Here we have 2 little spacers that are sitting at the distance I want them. Now I need to go ahead and put holes in the plate to match this, but it's very critical that this plate is established to be parallel with the center line of the crankshaft. I've got to get it square to the engine, and the reason for that is because when I mount my pump to that plate, squared to that plate, I have to have the pulley parallel to the drive pulley so that the belt doesn't try to walk off. And so I've got to make really sure everything is square here. Problem is these 2 holes are not in line with the crank. This one's higher than this one by some strange amount. So I've got to figure out where my holes need to go. Well, I know that this is 1-inch diameter, so what I'm going to do is bring my first hole in 1/2 inch in and 1/2 inch up, so it's tangent with this spacer here. Okay. The next thing I do is figure out where's this hole in relation to that hole. Well, I need to start with some measurements. And what I'm going to do is I need a reference point. And this right here, this machined point right here, is a locating point that was used in machining this block. And so I know that that's square. But the engine isn't sitting level. So I want to measure the angle here. Well, when I measure an angle, it's relative to the ground or the earth. It's not relative to this thing sitting on a rack in my garage. So I know that the engine is not level with the ground. So the first thing I have to determine is what's this angle and then what's this angle between these 2. Well, to do that, I've got a digital level, but it's 2 feet long and unwieldy and hard to fit in here. So I'll do what everybody does these days. I got a level on my phone. So I took the rubber case off, I put it up here, and I measure my level on this. Back from my thumb on the phone, here we go. So I've got an angle here of right at 2.3 degrees level with this. Then here, I've got an angle of 8.7 degrees uphill. So if I put this into my CAD, make that my 0 point, come 2.3 uphill with the engine, and then 8.7 for this, then rotate that all back down 2.3, I'll be parallel with the bottom of my plate. The other thing I need to know is the distance between these 2. Well, that's not as hard as you might think. I'll grab my caliper here, and I can actually put it between these 2, like so. And I can measure. Now I know that that's a tangent point between these 2, so I measure my tangent between these 2, and I come out with 1.280. So I'll make my 1-inch circle here, 1.280, another circle off of that, and then on this line put a circle that tangents to that circle, and now I can measure in CAD from this edge to the center of the hole and from the bottom to the center of the hole, and I'll put that on the mill, locate that on the part, and drill the hole there. With those 2 holes now then, my plate will be square. So that's the next step. One thing I didn't point out was I ended up with a pretty good gap between this connector and the side of the block, because in order to keep this place vertical, this plate here, and as tall as it is, I had to stop right here where it almost wants to contact the edge of the block where it tapers back in. So to get it out that far, that's why I ended up with my 1.25" measurement out here. Okay, so that puts the plate in this plane. So now I've got my 2 bolts. The third one I'll do last. I'm going to do that after I get the pump mounted, because I want to make sure I don't interfere with the pump or with the hose coming out of it. So now the next step is to come up with a block that holds the pump out here and sticks out and will bolt to this plate. So that's my next item. Let's change camera angles. The next thing to determine is going to be the block that holds this pump in place. And so I'm going to need a chunk of material to go in between these 2 plates. And I figure always start with a little extra material. You can mill more away. Adding is very difficult. So I need a plate that's going to be tall enough that can take from the bottom of this surface up here and mount, and that looks like about 3 inches, nice round number. The depth on it needs to go from here to here. If I back out just a little bit for adjustment, 2 inches. So 3 inches by 2 inches, and then the width of that block is the distance between these 2 plates, which is exactly 1 5/8 inches. So 1 5/8 by 2 by 3. So I'll make that block up and then start figuring out the rest of the mounting on that. I've got my block, and I've put it in between here. I can kind of move it around in here. And I've been doing a little fiddling on it. So if I sit it parallel with the top there, and I make the bottom of the block against the pump right there, that gives me a location. And I'm looking at to say, well, I got a lot of extra meat here. I can pull that back about to that line, that I don't need all that extra material. That'll tuck the pump a little closer in this way rather than sticking way out too far. So what I did was I just laid it up like that, and I took a scribe and scribed around this and through the holes, so I had points of reference to go by. And you will find that extremely hard to see on the video here, but there's a scribe line here and here. I didn't Dykem blue it, but I can see them. And that point and that point are the center points for my mounting holes. I'll do the one and then transfer punch the other one. These little lines here represent holding bolts. So I want to go between these 2 bolts for my bolt to come in back here from the back of this plate to bolt this on, and the other one will go down below the slot down here. So I'll use 2 bolts here that come from this side of the plate. I think I'll use flatheads, countersink them in, and then this will all have to be Loctited, but those 2 bolts will hold this plate in place nice and vertical. You can't do it with one, you got to have 2. And I'll drill this hole, put the pump on, transfer punch this one, and mill all this back off. So that'll get us much closer. Then I have to determine where forward and back and up and down this needs to go. Locate those holes in this plate, and then once I get it mounted, I can take anything in front of this block here and mill it off, get rid of that. Just extra material, could get in the way, it's weight. So I'm going to be trimming this plate up some more as we go. But that's the next step. So I'm going to get busy at that, mill off the extra, drill a couple of holes, and drill and tap the back side of this dead center back here with the threads for deadhead bolts back in here. So those will be blind holes. Okay, that's going to take a little while. Okay, I've got my little block here that pivots in and out, and it's got holes in the back for mounting. And so what I need to do now is determine how far forward or back this needs to sit on this plate and determine that distance to the front of the block. To do that, I've taken a piece of flat bar here and grab hold of my pulley, clamp it, and I can swing it down and feel when I'm right at the front edge of this pulley here where I've got a flange. And I'm going to bring it up until this is flush on top. And so if that's flush on top, that's just touching, then I can measure right back here with my dial indicator, and I'm at 0.850. So that means that I'll be able to remove 0.850 off the front of this, and then I know how far back my holes are here. It's 13/16 to the center line of those holes. And I also know the distance down and over. So I can drill those holes from the back and countersink them, bolt this plate on, and that would line me up. Now, interesting thing is that this distance isn't extremely critical. If I'm off just a little, it's not a big deal. I know what you're thinking, blasphemy. How could I possibly say that? Well, the reason is this pulley on this shaft has a lot of ability to move in and out. There's a lot of shaft back here. So I can come out 1/8 from here. I can go back. There's a good 1/2 inch behind there. So I can move this pulley in and out to line up for the last critical amount when I put the belt on. So I've got room to play here, but that's going to get me extremely close. I'm within 20 thousandths. So this will be just fine. So now it's time to mark this plate, drill it from the back, countersink it, and bolt this all together. Now things are really starting to take shape. This is got to be all cleaned up yet, but roughly speaking, everything is bolted in place solidly here. I still have to do the mount here, but my pump pivots up and down for my tension. It's good solid front to back. This will clamp down nicely, so I'll remove the front edge of this plate later, get rid of this extra material, and then there's some more trimming on the back. But the first thing now is this right here. I've got to get this bracket to go from here to the plate. So I need a little L bracket to come up and over and hit that. I also have a nut directly behind here on this that I have to avoid when doing that. So I've got to make sure that I leave enough room for this back of this bolt and I don't get in the way of that. But that's going to be a little L bracket that comes down and in. And I might just recess it for the end of this bolt or something. That would capture the nut. So looks like that's the next thing. And then it will be completely mounted, and then I can start figuring out where I can trim off excess material and dress it up. So all that to come. Okay, I got this nice solid mount now. Everything is here. It has its pivot. It's solid as it can be. So this is great. So it's time to clean this thing up. And what I mean by that is dress it up so it looks nice and it isn't overbuilt. Now, what I mean by that is, you look at this, it's just big chunks like a big Lego. So I can get rid of a lot of metal on here that I'm not using. So I can start by taking this whole front edge off. I can cut back this corner here to the bottom. I can cut the back top corner off back here that I'm not using. And then I can start rounding all the edges and dress everything up and countersink these bolts down here and dress this thing to look pretty. So now that's the next thing to do. So mark it all up, chop it all up, and then I'll show you how I'm going to round the corners off. I'll show you a little trick I do to dress my parts up a little. Now, obviously, if this was a show car, these parts would be polished to a super high gloss. That's not going to be necessary on a race car because it's not going to make the car faster. It's a huge amount of work, and this thing is going to be out in the dirt, getting dirty, nasty. It will get washed. It will get aluminum brightener when necessary to keep things looking decent, but it doesn't need to be polished. However, it also looks a bit Lego-ish with just square edges, and I like to clean it up a little and dress it up where I can to make things kind of look decent. And to do that, I use my router table with a carbide router bit that is a 1/8 inch rounding bit. Sometimes I use a 1/4, and it has a bearing that you just follow along the edge and it will carve that around real pretty. Let me give you a real quick example of that. And there we go. Really does a nice little rounding on them. You don't have the sharp edges to cut you. Very nice for aesthetics and everything else. So I've marked all the edges that I want to do that to. I'm going to go ahead and do that, and then I'll just show you what it looks like when it's all put together. Okay? Right, and there you are in all its glory. All cleaned up and installed, up, down, and around. You can see it from different angles. That is blue Loctited in and good to go. So time to put the pump on and measure for a belt. The belt is a standard 1-inch wide L pitch industrial timing belt, easily available. A length, at collapsed I'm at 32 1/4, all the way out I'm at 34. So I'll try to find something that goes in between that range, something in the 33. And then I'll be able to put the belt on and tighten it up, make sure about my alignment, and move the pulley as necessary. And this part is good. So the next thing after this now is to go around. I got to go around and start looking at all of my locations of all of my fittings and figure out where I need straights, 45s, 90s, AN 6s, 12s, 10s, and get all those ordered along with all of the hose. So I'll have to fabricate all my hoses up. So plan on that being another $500 probably, but it all adds up in a big hurry. But that will get me my oil supply system complete, oil filter, the tank, and the power steering hoses all in. And that is a big move down the road. So this was a very tricky bit, and I hope you enjoyed what it took to build that. But it's good, it's solid, it isn't going to go away on me. So onward to the next thing.